Hello everybody, I hope you're doing well, and I am making another video today to help you with lesson 5, and we're starting to talk about measures of variation. And we've come from this last lesson where we talked about the certain characteristics such as mean, median, mode, and range, and each of those important characteristics are useful in different ways, and today we're going to look at a different idea which talks about the distances between my data points. Okay, so everything today is going to talk about some sort of distance with my data set. So with this lesson today, there are two main things that you need to know. So the first thing is mean absolute deviation, and the mean absolute deviation basically talks about how far each data point is individually. Okay, so it's saying that each data point on average is going to be this far apart. Now that's not always going to be exact, right? It's going to be skewed a little bit because it's an average. Average isn't always um, the best form of explaining data because it can be skewed, but a lot of times it's the most useful. So that's what mean absolute deviation is. Standard deviation talks about the whole data set in general, right? And we won't find a standard deviation. In fact, they'll give you the standard deviation. What we'll have to find today is the the range that of the standard deviation, right? So for example, right, we might have a mean of 15, right? And we say that the standard deviation is 5, right? And say we're talking about, I don't know, score, like a score, right? And 15 is the average, but the standard deviation is within 5 points, right? So that means we're going to add 5 to it, so 20, and then subtract 5, so 15 minus 5 is 10. So the majority of my data set is within 10 points and 20 points. Okay, so that's what standard deviation really talks about, is the overall data set range. Whereas the mean absolute deviation talks about each individual data point. So your assignment today was on page 713, numbers 1 through 4. And number 4, there's a lot there, but what I'm going to do is kind of help you out with like number 1 and 3, and that'll help you with like number 4, but there's kind of a lot of information given to you. Okay, so on number 1, we have to find the mean absolute deviation of each set and then round to the nearest tenth if necessary. Describe what the mean absolute deviation represents. So on number 1, we have the average speeds of selected animals in miles per hour. So we don't know the animals. At this point, that's not important because all we care about here is the speeds themselves. So what we're going to do is we're going to find the mean absolute deviation. So the first thing I have to do to find the mean absolute deviation is to find the mean of my data set, or the average. So remember, to find the average, I have to take all of my data points and add them together. So 70 plus 40 plus 45 plus 42 plus 40 plus 36, and then divide by how many data sets there are. In this case, there are 6. So if I take my data points and I add them together, so 70 plus 40 plus 45 plus 42 plus 40 plus 36, and I get 273 divided by 6, which is 45.5. So the average speed for these animals is 45.5 miles per hour. Now, it didn't ask us to find the mean. It asked us to find the mean absolute deviation. So what I have to do at this point is subtract my mean from each point. right? So each of my data points I have to subtract 45.5, and I also want to make sure it's in absolute value. And the reason why we put it in absolute value is because we're finding the distance between the points. And distance is always positive. So remember, absolute value makes it positive, and that is what we want since we're dealing with distance. So for example, I'm going to take 70, which is my first data point, and I'm going to subtract 45.5 in absolute value. And if I do that, I should get 24.5. And I'm going to do the same thing with 40. So 40 minus 45.5. And if I do that, I'm going to get negative 5.5. But since it's absolute value, it makes it positive 5.5. Same thing with 45 minus 45.5. In this case, I'm going to get negative 0.5, but the absolute value makes it positive. And then I have 42 minus 45.5. In which case I'm going to get 3.5. Then I have 40 minus 45.5. And once again, that's going to be 5.5. And then last but not least, I have 30 minus 36 minus 45.5. And I get positive 9.5. Okay, so now we've found all of these distances from the mean, and now what I have to do is find the average distance from the mean. So I got to find the average one more time. I've got to take all of these data points that I've just found right here, and I have to add them together, and then since I'm finding the average, divide by how many there are. So I'm going to take 24.5 plus 5.5 plus 0.5 plus 3.5 plus 5.5 plus 9.5. And I get 49 for my total here. So when I add all of those up, I get 49. And divide by how many there are. In this case, there are 6. So 49 divided by 6 gives me 81.2 since I'm rounding to the nearest tenth. Or sorry, 8.2 since I'm rounding to the nearest tenth. Okay, so this number that I just found right here, 8.2, that is my mean absolute deviation. Okay, that means, so the mean absolute deviation, I'm going to abbreviate that as MAD here, equals 8.2, which means that each of my data points are about 8.2 units apart, right? So each, so when it says describe what the mean absolute deviation represents, we could say the speeds are about 8.2 miles per hour apart, right, between my data sets, because that's what I'm looking at with mean absolute deviation is, okay, is how far apart are my data points? Okay, so that's what you do with like number 2. You're going to follow the same process where you find the mean, subtract it, find the absolute value, and then find that last average once again. Okay, so you'll do that again with number 2 and with part A on number 4. Okay, so that was with mean absolute deviation. What you'll have to look at for like number 3 and part B on number 4 is standard deviation. So on number 3 it says refer to table in exercise 1. The standard deviation of the average animal speed is about 11.3 miles per hour. And it says describe the data values that are within 1 standard deviation of the mean, right? So remember, we had that mean, and we found 45.5. So to find the range of values for the standard deviation, you're going to take this number that they give you, and you're going to add and subtract it from your mean. So I'm going to add 11.3 and subtract 11.3 from 45.5. So my larger value for my numbers is 56.8, and my smaller value for my numbers is 34.2. Okay? And by finding these numbers, what it tells me is that the majority of my data points are going to be between 34.2 and 56.8. Okay? So for example, if I was trying to make a prediction on, like, I don't know, how fast one of these animals was going to run, I'm not going to guess 20 miles per hour because that doesn't fall within the standard deviation, right? If I want to have a good chance of guessing it correctly, I'm going to pick something within this range, okay? So what that tells me, when it says describe the data values that are within one standard deviation, we can say that most of the speeds are above 34.2 miles per hour and below 56.8 miles per hour. Okay, so the majority of my data points are within that range. Okay, so I hope that kind of makes sense with standard deviation, and you would apply that same concept with part B on number 4. Okay, so I'm not going to actually do number 4, but I'm going to talk you through it for a minute. So on number 4, you have these volleyball scores, and on the left-hand side, you have the men's scores, and on the right-hand side, you have the women's scores. To find the mean absolute deviation, you're going to do the same thing we just did in number 1, but you have to do them separately, and then we're going to compare them later. So you have to do the men's scores first, where you find the mean, and then you subtract it from each of those scores, and then find the average once again of those. And then you'll do the same thing with the women's side, and then you're going to compare them. You're just going to write a sentence or two describing the distance between each of your data sets, right? And then be careful on number 4 because it says round to the nearest hundredth, okay? That one's a little bit different. And then on part B, you're going to find the standard deviation, like what we just did on number 3, and then describe how those two relate and how they refer to part A. So I hope that kind of makes sense, and if you need help, please feel free to email me, and I will do the best that I can to give you the assistance that you need. And like I said, you guys, I hope you're doing well, and you're doing a great job, and I hope you have a great day. Thanks.